Now we'll discuss 2012 UGB paper, and the first question is, let XYZ be the angles of a triangle. Prove that 10x by 2, 10y by 2 plus 10x by 2, 10z by 2 plus 10z by 2 into 10y by 2 is equal to 1. Now we know that x, y and z, they are angles of a triangle. So we can write x plus y plus z equals pi. Then we can write x by 2 plus y by 2 will be equal to pi by 2 minus z by 2. Now we'll take 10 both sides. We'll write 10 x by 2 plus y by 2 and it will be equal to 10 pi by 2 minus z by 2. Now this is 10a plus b. So it will be 10x by 2 plus 10y by 2 upon 1 minus 10x by 2 into 10y by 2, and here it will be 1090 minus theta, which is cot z by 2, and we can also write it as 1 upon 10 z by 2. Now if we cross multiply, we can write this as 10x by 2 into 10z by 2 plus 10y by 2 into 10z by 2 plus 10x by 2 into 10y by 2. It is equal to 1, and this is what we need to prove in part 1. Now the second part, it says, using first or otherwise prove that 10x by 2 into 10y by 2 into 10z by 2 is always less than or equal to 1 upon 3 root 3. Now we know that since x, y, z, they are angles of a triangle, then each of x by 2, y by 2 and z by 2, they lie in first quadrant. That means 10x by 2, 10y by 2 and 10z by 2, they will be positive numbers. Now if we take 10x by 2 into 10y by 2 as A, this number is B and this number is C, then arithmetic mean will always be greater than or equal to its geometric mean. So we can write 10x by 2 into 10y by 2 plus 10x by 2 into 10y by 2 plus 10z by 2 into 10y by 2 by 3. It will always be greater than or equal to their product, and their product will be 10x by 2 into 10y by 2 into 10z by 2 to the power 2 by 3. Now we know that this sum, it is equal to 1. So we can write 10x by 2 into 10y by 2 into 10z by 2 whole to the power 2 by 3. It will be less than or equal to, now this is 1, so it will be 1 by 3. Now we can also write this as 10x by 2 into 10y by 2 into 10z by 2 will be less than or equal to 1 upon 3 to the power 3 by 2, which is nothing but 1 upon 3 root 3. And that's your second part. Now question number 2 is, let alpha be a real number. Consider the function gx, which is alpha plus mod x square e to the power 5 minus mod x square for x belongs to R. Now the first part is, determine the values of alpha for which g is continuous at all x. Now we know that mod of x, it's a continuous function. Exponential function, it is also continuous. Any polynomial function is also continuous. So their composition and their product will also be a continuous function. So this gx, it is continuous for all x for alpha belongs to R. So whatever may be the value of alpha, this function will always be a continuous function. Now the second part is determine the values of alpha for which g is differentiable at all x. Now for the second part, we can express this definition gx as alpha minus x whole square into e to the power 5 plus x square if x is less than 0, and it will be alpha plus x whole square e to the power 5 minus x square when x is greater than or equal to 0. Now this first part, function is continuous and differentiable, and the second part also, this function is continuous and differentiable. Now there is a definition change at 0. So we just have to check differentiability of this function at x equals 0. Now what we'll do is we'll find g dash x when x is less than 0. So if x is less than 0, then g dash x will be alpha minus x whole square e to the power 5 plus x whole square into 2 5 plus x and then plus e to the power 5 plus x whole square into, this is 2 alpha minus x into minus 1. If we find its left hand derivative, now its left hand derivative at 0, which is g dash 0 negative, it will be alpha square into e to the power 25 into 10 plus e to the power 25 into minus 2 alpha. We can take e to the power 25 common, then we can write e to the power 25 and then 10 alpha square minus 2 alpha. Now we'll find derivative of this function when x is greater than or equal to 0. In that case, g dash x will be alpha plus x whole square e to the power 5 minus x whole square into 2 5 minus x into minus 1 plus e to the power 5 minus x whole square into 2 alpha plus x. Now we'll find g dash 0 positive. It will be alpha square into e to the power 25 into minus 10 plus e to the power 25 into 2 alpha. Now again we'll take e to the power 25 common. So we'll get minus 10 alpha square plus 2 alpha. That's your right hand derivative. Now this function will be differentiable at x equals 0 when left hand derivative is equal to right hand derivative. That is when e to the power 25 10 alpha square minus 2 alpha, it is equal to e to the power 25 minus 10 alpha square plus 2 alpha. Now e to the power 25 will cancel, so we'll get 10 alpha square minus 2 alpha equals 0. That is, the value of alpha is either 0 or the value of alpha is 1 by 5. So this function gx will be differentiable when alpha is 0 or alpha is 1 by 5. Now the third question is, write the set of all positive integers in triangular array as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12, 13, 14, 15. That says find the row number and column number where 20096 occurs. For example, 8 appears in third row and second column. Now if we look at this first row, then here we have 1, this is 3, this is 6, 10, 15, which is nothing but sum of n natural numbers. For this first row, first column, this is 1. For this first row, second column, it is 1 plus 2, which is 3. Here it is 1 plus 2 plus 3. Here it is 1 plus 2 plus 3 plus 4. This is 1 plus 2 plus 3 plus 4 plus 5. So at first row and nth column, this number, it will be n into n plus 1 by 2. Now we need to find row number and column number of 20096. Now if we take n as 200 in first row and 200th column, the number will be 200 and it will be 201 by 2, which is 20100. Now we know that numbers move in this progression. So this is C200, then 199, 198, 197, 196, and this is R1, R2, R3, R4 and R5. So at R1 C200 number is 20100. Now at R2 C199 number will be 20099. Now for R3 C198 will be 20098. Now for 197 and R4 it will be 20097, and then finally at C196 and R5 this number will be 20096. So this number 20096, it appears at 5th row and 196th column. Now question number 4 is, we need to show that this polynomial, which is x to the power 8 minus x to the power 7 plus x square minus x plus 15 equals to 0, has no real root. Now what we'll do is, we'll take a function fx as x to the power 8 minus x to the power 7 plus x square minus x plus 15. Now we'll consider this first case when x is less than 0. Now if x is less than 0, then this fx, which is x to the power 8 minus x to the power 7 plus x square minus x plus 15, this value will be positive. This is also positive. It will be positive. It will also be positive, and then plus 15. Then this fx will be greater than 0. So if x is less than 0, this number is a positive number. Now we consider the second case when x lies between 0 and 1. Now we know that when the number lies between 0 and 1, then x to the power 8 will be less than or equal to x to the power 7 will be less than or equal to x square will be less than or equal to x, and will be less than 15. Now we can rearrange this fx as x to the power 8 plus x square minus x to the power 7 plus 15 minus x. Now this 15 minus x will be positive, x square minus x to the power 7 will be positive, and x to the power 8 is also positive. So that means this fx is also positive when x lies between 0 and 1. Now we'll consider this third and final case when x is greater than or equal to 1. Now if x is greater than or equal to 1, then in that case x to the power 8 will be greater than or equal to x to the power 7 will be greater than or equal to x square will be greater than or equal to x. Now we can write this fx as x to the power 8 minus x to the power 7 plus x square minus x plus 15. Now this is positive, and this is positive. That means it is greater than 0. So for all x belongs to R, this fx is greater than 0. That means graph of fx will always lie above x-axis. So this function, it will never intersect x-axis. That means this equation, it will have no real root. And that is the answer to this question. Now question number 5 is, let m be a natural number with digits consisting entirely of 6's and 0's. Prove that m is not the square of a natural number. Now we'll prove this question using contradiction. So what we'll do is, we'll say let m be the square of a natural number. Say k. So we can write m equals k square. Now since this number, it contains the digit 6 and 0, that means this m, it is an even number. If m is even, that means 2 divides m. If 2 divides m, it means 2 divides k square. And if 2 divides k square, that means 2 divides k. So this k, it must be of the form sum 2l. So we can write this m will be sum 4l square. Now again we can say this m is of the form 4l square. That means 4 divides m. Now since all the digits, they are made of either 6's or 0's, that means sum of digits will be some multiple of 6. Say sum 6t. And if sum of digits is 6t, that means this number m, it is divisible by 3. So we can write 3 divides m. If 3 divides m, that means 3 divides k square. It means 3 divides k. So if k is sum 3l dash, then this m will be sum 9l dash square, that is 9 divides m. So 4 divides m and 9 divides m, and GCD of 4 and 9 is 1. So it clearly means that 36 divides m. So this m, it is divisible by 36. Now we'll consider two cases. Case 1, when this number m, it ends with 6. And the second case, when m ends with 0. Now if m, it ends with 6, then m by 6 will be, and here this value will be 1. That means this m by 6, it is an odd number. And if m by 6 is an odd number, then 36 doesn't divide m, which is a contradiction. So that means this m, it cannot end with 6. Now what if m ends with 0? Now if m, it ends with 0, that means 5 divides m, and since this m is a perfect square, we can say 5 square divides m. Now m is divisible by 25 and m is divisible by 36, and GCD of 36 and 25 is 1. So from here we can say 900 divides m, or m is divisible by 100. So if m ends with 0, then it has to be 2 zeros. Now if 100 divides m, then we can write m dash as m by 100. Now this m dash, either it can end with 6 or it can end with 0. Now if it ends with 6, then from the same argument we can say that it cannot be a perfect square. We'll get a contradiction. And then if it ends with 0, then 5 divides m dash and 5 square divides m dash. So again we can say it will have 2 zeros. So we can keep dividing it by 100. So there'll be this one case when we'll have this 6 here, and in that case we can say we have a contradiction. We cannot have 0, 0, 0, 0 for all the numbers. So in all the cases, we end up getting a contradiction. So from contradiction, we can say that this m, it is not the square of a natural number. Now question number 6 is, show that amongst the triangles with base A and perimeter A plus B, the maximum area is obtained when the other two sides have equal length B by 2. So we have this triangle whose base is A and whose perimeter is B. Now suppose this length is X, then this length will be B minus X. Now its perimeter is A plus B, so value of S is A plus B by 2. Then we can write area square as S minus A, S minus X, and then S minus B plus X. Now S is A plus B by 2. So it will be A plus B by 2. S minus A will be B minus A by 2. S minus X will be A plus B minus 2x by 2. And here this value, it will be A minus B plus 2x by 2. Now we can write this delta square as 1 by 8 b square minus a square, and here it will be a square minus b minus 2x whole square. Now we want this area to be maximum. So what we'll do is we'll differentiate this area with respect to x. So we can write 2 delta into d delta upon dx. It will be 1 by 8 b square minus a square, and then minus 2 b minus 2x into minus 2 equals to 0. Then from here we'll get the value of x as b by 2. Now this is b by 2. Rightmost is this is plus. Now this is minus and minus plus, and coefficient of x is negative. So this is minus and this is plus. So sign of derivative changes from plus to minus. That means at x equals b by 2, it is a point of local maxima. So this area, it will be maximum when the value of x is b by 2. So if the value of x is b by 2, then this other length will be b minus b by 2, which again is b by 2. So among all the triangles with base A and perimeter A plus B, the maximum area is obtained when the other two sides have equal length b by 2. Now the second part of the question is, using the result 1 or otherwise, show that amongst the quadrilateral of given perimeter, the square has maximum area. So we have this quadrilateral, say A, B, C, D, and its perimeter is fixed. Now suppose this is A, B, C, and D, and A plus B plus C plus D is some fixed number, say K. Now we consider this diagonal AC. Then for fixed value of AC, this triangle will have maximum area when the length of other two sides is equal. That means from here we will get this condition that A is equal to B. Now in the same way, area of this triangle will be maximum when D is equal to C. Now we consider triangles along this diagonal BD. Then again this area BDC will be maximum when B equals C and this area will be maximum when A equals D. That means we'll have this maximum area when all the four sides are same. That is when A equals B equals C equals D. That means we have a rhombus. Now suppose this is A, and A. And say this angle is theta. Now area of rhombus will be 1 by 2 A square sine theta into 2. So it will be A square sine theta. Now maximum value of sine theta is 1. So this area will be maximum and it will be A square, and it will be maximum when sine theta is 1. That is when theta is pi by 2. So if theta is pi by 2, that means this rhombus will be a square. So area of this quadrilateral with a given perimeter will be maximum if this quadrilateral is a square. Now here the question is, let A be greater than 0 and B be greater than A. Consider two circles with radius A and B and centers at A, 0 and 0, B. Going by the figure, I think this should be B, 0. And let C be the center of any circle in the crescent shaped region M between the two circles, and it is tangent to both as shown in the figure. And it says determine the locus of C as its circle transverses through region M maintaining tangency. Now we have to find locus of this point C. We'll take this point as alpha, beta, and let the variable radius of this circle be R. Now these two circles, they touch each other externally, and if they touch each other externally, then we can write under root of alpha minus A whole square plus beta square will be equal to R1 plus R2. Now R1 is A and R2 is simply R. Now this bigger circle and this circle with center C, they touch each other internally. Then we can write under root of alpha minus B square plus beta square B minus R. Now we'll add them both. So we'll add them both, we'll get under root of alpha minus A square plus beta square plus under root of alpha minus B square plus beta square, and L be equal to A plus B. Now this distance, it is nothing but it is distance between these two centers. Now this is A and this is C. So we can write AC plus, now the other distance is distance from B. So AC plus BC, it is equal to A plus B. Now we know that if the sum of distance of a point from two fixed points, it is constant, then the locus of this point will be an ellipse. So the center of this smaller circle C, it will lie on ellipse whose foci are at A, 0 and B, 0, and which passes through origin. So this ellipse will pass through origin and its foci will be at A, B. Now we have to write equation of this ellipse. This point A is A, 0, and this point B is B, 0, and it passes through 0, 0. Now center of this ellipse will be at A plus B by 2, 0. Now distance of vertex from center, it is A. So if we write A, it will be simply A plus B by 2, and distance between center and one of the foci will be A into E. So A into E, it will be A plus B by 2 minus A, which is B minus A by 2. Now if we put A as A plus B by 2, we'll get E as B minus A upon B plus A. So now we have A, we have E, we can find length of minor axis. So we'll find b square and it'll be a square into 1 minus e square. Now a square is a plus b by 2 whole square, and this is 1 minus, and it is b minus a upon b plus a whole square. Now b plus a whole square will cancel. So we'll get this b square as ab. Now once we have center and we have a and b, we can write equation of this ellipse as x minus a plus b by 2 whole square upon a square, which is a plus b by 2 square, plus y square upon b square, which is ab, and it'll be equal to 1, and that is the locus of this circle. Now the next question is, let n be greater than or equal to 1 and S be a set 1, 2, 3 up to n. For a function f from S to S, a subset D is said to be invariant under f if fx belongs to D for all x belongs to D. Now note that the empty subset and S are invariant for all f. Let degree of f be the number of subsets of S invariants under f. Now show that there is a function f from S to S such that degree of f is 2. Now we are given this function from S to S. So this is 1, 2, 3 up to n, and this is 1, 2, 3 up to n. Now suppose we define this function fx as x plus 1 if x is unequal to n, and this is 1 when x is equal to n. So when x is 1, it is mapped to 2, 2 is mapped to 3, 3 is mapped to 4, and n minus 1, it is mapped to n, and then when x is n, it is mapped to 1. Now we take any subset, say 1, 2, 3 up to k, and 1, 2, 3 up to k. Now 1 is mapped to 2, 2 is mapped to 3, and k minus 1 is mapped to k, but we do not have an image for k. So this function, it cannot have invariant for any subset except for empty set and the entire set S. For this defined function fx, degree of f is simply 2. Now second part is further show that for any k such that k lies between 1 and n, there is a function f from S to S such that degree of f is equal to 2 to the power k. Now one way of defining such function is using permutations. So we have this function f which is defined on 1, 2, 3 up to n, and if we consider permutations of these numbers, say 2, 3, 5, 1, then we can define this function in such a way that this function has exactly k cycles where k lies between 1 and n. Now if we consider each cycle as a subset, then we'll have d1, d2 and dk subsets which are disjoint and bijective. So this function f, it is a bijective function and it has exactly k cycles. Now condition we have taken is this ith cycle, it corresponds to an invariant subset di in such a way that S is a union of all di's, and all these di's, they are pairwise disjoint. Now each invariant subset of this function it'll be union of some DIs. In how many ways you can find union of DIs? So for any subset, for each DI, we have two options. So for D1, we have two options. For D2, we have two options. And for DK, we have two options. So total number of such invariant subset will be simply 2 to the power k. That means degree of f, it will be 2 to the power k. So there exists a function f from S to S such that degree of f is simply 2 to the power